One of the most controversial questions we may have. One that has haunted humanity since the beginning of time. What lies beyond known borders? Or, what goes beyond the boundaries of our maps? The purpose of the previous question is to question what lies beyond the boundaries of the universe. And the answer cannot be reduced to a word or a sentence. To answer what is outside the universe, we first need to know what we mean by the term universe. If you consider it to mean literally all things that may exist everywhere and at all times, then there can be nothing outside of it. Even if you imagine that the universe has a finite size, and you imagine something outside that size, everything outside must be placed within the universe. If the universe is a void with no form, no name, this is still something and is on the list of all things, and therefore by definition it is part of the universe. And if the size of the universe is infinite, you don't have to worry about this dilemma. The universe with all that exists is large, infinite and infinite. So there is nothing outside of it to talk about. But there is something beyond the confines of the observable universe. The universe is very old, and light travels very fast. But we have not received light from all galaxies in the history of the universe. The observable universe is estimated to be about 90 billion light years wide. And a cluster of random galaxies and stars may exist beyond that limit. But beyond that, the answer is difficult.Bending condition. Cosmologists are not sure whether the universe is large and infinite or is it just too large. Instead, astronomers look at its curvature. The geometric curvature of the universe tells us about its general shape. If the universe were perfectly flat, it could be infinite. And if it were curved, like the surface of Earth, it would be finite in size. Current scales and observation processes suggest that the universe is completely flat. So you might think that the universe is infinite. But it's not that simple. Even in the case of a flat universe, it doesn't have to be infinite. Let's take, for example, the surface of a cylinder. They are geometrically flat, because the parallel lines drawn on the surface remain parallel, which is one of the definitions of superficiality. Yet the cylinder has a finite size. The same may be true of the universe. And it may be completely flat and at the same time close to itself. Even if the universe is finite, this does not necessarily mean that it has a limit or that things exist outside it. The three-dimensional universe may exist within a larger, multidimensional structure. This is a good theory and it's part of some strange physical models. But right now we don't have any way to test this. And it doesn't actually affect the universe's daily operations. But if the size of the universe is limited, it doesn't necessarily exist in something else.Viewpoint. When you imagine the universe, you might think of it as a giant ball full of stars, galaxies, and all sorts of interesting astrophysical objects. You might imagine what it looks like from the outside. Just like seeing an astronaut from a quiet orbit above it. The existence of the universe does not need the external perspective. The universe simply exists. Having a three-dimensional universe is mathematically consistent without the need for something outside it. When you imagine the universe as a sphere floating in emptiness, you are practicing a mental trick that mathematics doesn't need. The existence of a finite universe with nothing outside it is impossible. And an empty void, nothing, is not mathematically defined in a complete and comprehensive manner. In fact, your question, what is outside the universe, is a simulation of the question, what sound does purple make? It's an illogical question. Because you're trying to combine two unrelated concepts. It is indeed plausible that there is something beyond the boundaries of the universe. But again, this doesn't have to be the case. There's nothing in mathematics that describes what's outside the universe. If all of this sounds complicated and confusing, don't worry. The whole point of developing complex mathematics is to have tools that give us the ability to deal with concepts beyond our imagination. And this is one of the strengths of modern cosmology. It enables us to study the unimaginable. Paul Sutter is an astrophysicist at the State University of New York Stony Brook and the Flatiron Institute, host of Ask an Astronaut and Space Radio, and author of How to Die in Space. It is one of the most pressing questions you can ask. A question that humans have been asking since the beginning of time. What goes beyond known limits? What's next after the edge of our maps? The final version of this question is, what lies beyond the boundaries of the universe? Answer. Well, it's complicated. To answer the question of what is outside the universe, We first need to determine exactly what we mean by the word universe. If you consider it to mean literally all things that can exist in all space and time, then there can't be anything outside the universe. Even if you imagine that the universe has a finite size, and you imagine something outside that size, then everything that is outside must also be included in the universe. Even if the universe is devoid of any form, no name, and devoid of anything at all, this is still something and counts in the list of all things, and therefore, by definition, part of the universe. If the size of the universe is unlimited, then you don't have to worry about this mystery. The universe, being all that exists, is infinitely large and has no edge, so it does not exist outside so that it can be talked about. Oh, sure, there's an external part of the patch of the universe that can be observed. The universe is very old, and light travels only very fast. Therefore, in the history of the universe, we have not received light from every galaxy. The current width of the observable universe is about 90 billion light-years. Presumably, beyond those boundaries, there is a host of other random stars and galaxies. But then, it's hard to say. Bending condition cosmologists are not sure if the universe is infinitely large or too large. To measure the universe, astronomers instead look at its curvature. The geometric curve on large scales of the universe tells us about its general shape. If the universe is completely geometrically flat, it can be infinite. If it is curved, like the surface of the Earth, its size will be limited. Current observations and measurements of the curvature of the universe indicate that it is almost completely flat. You might think that this means that the universe is infinite. But it's not so simple. Even in the case of a flat universe, the universe does not have to be infinitely large. Take, for example, the surface of the cylinder. It is geometrically flat, because the parallel lines drawn on the surface remain parallel. This is one of the definitions of flatness. Yet they are of limited size. The same can apply to the universe. It can be completely flat but closed to itself. But even if the universe is finite, this does not necessarily mean that there is an edge or exterior. Our three-dimensional universe can be embedded in a larger, multidimensional structure. This is perfectly fine and is already part of some strange models of physics. But right now, we have no way to test this, and it doesn't really affect the day-to-day operations of the universe. I know this is very headachy. But even if the universe has a limited size, it doesn't need to be included. A matter of perspective. When you imagine the universe, you might think of a giant ball full of stars, galaxies, and all kinds of interesting astrophysical objects. You might imagine what it looks like from the outside, like seeing an astronaut of the globe from a quiet orbit above it. But the universe does not need this external perspective in order to exist. Simply universe. Defining a three-dimensional universe without the need for an external existence of that universe is mathematically completely subjective. When you imagine the universe as a ball floating in the middle of nothingness, you are playing a mental trick on yourself that mathematics does not require. It is true that it seems impossible to have a finite universe in which there is nothing outside it. Not even nothing in the sense of emptiness, mathematically indefinite in whole and in totality. In fact, asking what is outside the universe is like asking what sound does purple make. It is an illogical question, because you are trying to combine two unrelated concepts. It is quite possible that our being him is already out. But again, that doesn't have to be the case. There is nothing in mathematics that describes the universe that requires the outside. If all this sounds complicated and confusing, don't worry. The whole goal of developing complex mathematics is to have the tools that give us the ability to manipulate concepts beyond what we can imagine. And this is one of the forces of modern cosmology. It allows us to study the unimaginable. The universe is one of the most interesting philosophical and scientific topics, because it contains many secrets and mysteries that have not yet been solved. Among these mysteries is what exists after the edge of the universe. What is it? First, it should be noted that the outer edge of the universe is not known exactly, as scientists are not sure of the fact that there are limits to the universe. However, The outer limits of the universe are thought to be very large distances away from us, ranging from several billion to several trillion light years. Determining what exists beyond the edge of the universe is difficult to conceive, as the universe is abstract from anything conceivable, and there is no kind of gravity, mass, or light beyond the boundaries of the universe. Since the outer edge of the universe lies so far away from us, any knowledge about what's out there may remain fanciful or only theoretical. Scientists generally believe that the space between planets and stars in the universe is not a complete vacuum, but contains small amounts of small astronomical particles and scattered cosmic radiation. Since there is nothing beyond the limits of the universe, it is likely that there is nothing conceivable. It is difficult to talk about what exists beyond the edge of the universe without including philosophy in the equation, as the subject has many philosophical aspects. One of the philosophical aspects of this issue is the question of existence and nothingness, whether existence ends at the limits of the universe or whether there is something else that exists far away from us that we cannot see or explain. This question is part of the fundamental question of philosophy: why is there something and not nothingness? On the other hand, this issue also raises questions about the reality of time and space, and whether there is a space or time characterized by the non-existence of the universe or the actual existence. Some philosophers and scientists believe that time and space are not devoid of actual existence, but are influenced by the existence and interactions of the universe. In the end, it should be noted that this issue is still being investigated and researched, and although scientists have obtained considerable information about the universe and its structure, they still face many challenges in understanding what exists beyond the boundaries of the universe. However, recent developments in theoretical physics, astronomy and cosmology have opened the door to the possibility of reaching new answers on this interesting issue. This issue also includes questions related to the dark universe and dark energy, which are astronomical concepts that speak of the existence of matter and energy that cannot be seen or measured by currently available astronomical instruments. This means that these objects and energy in outer space may be able to form a reality different from what we know now, and therefore there could be something different or strange away from us. There is also the multiverse theory, which is the hypothesis that there are several parallel universes to our current universe, meaning that there are other universes that may be significantly different from our current universe, and therefore there could be something else that exists far from us in these parallel universes. Although this issue may raise many questions and controversy, it is still just hypotheses and theories that need more research and scientific analysis to confirm their validity. However, this interesting issue remains a popular topic in philosophy and science, and will continue to be studied and analyzed for a long period of time.